Okay, ready to start Module 7, Lesson 4B. So a lot of this is review. If you want to turn off the video now and work through it, you will see you know probably almost everything in it. But it's kind of trying to tie stuff together before we go to our graphing and then on to systems of equations. Because we have four big topics, I guess, in Module 7. We have slope, which we already did. We have writing equation of a line, which we did in the last lesson A. And then we have graphing lines, and then we have solving equations. So those are our four big things for Module 4. So this is kind of tying everything together that we've learned so far. So I'm going to go a little bit quickly through it. If you have questions, be sure and email me because I'm happy to answer them. But like I said, most of this will be very familiar. So there's three forms of an equation of a line. There is standard form, which we haven't talked about. There's slope-intercept form, which we have talked about. And there's point-slope form, which our last lesson was about. So this is standard form. The reason we haven't talked about it yet is because we really don't use it much. It's just pretty. It doesn't give me a point. It doesn't give me a slope. It's just pretty. There's no fractions or decimals in it. X and Y are on the left in alphabetical order, and the constant, the number, is on the right. So basically, it's the pretty form. So teachers kind of think it's a waste of time to ask you to write answers in that form. I will not ask you to write any of your answers in that form. Almost 99.9999% of the time, I will ask you to put your answers in slope-intercept form. So remember how we started with point-slope form in the last lesson, but we ended by circling the answer that said y equals mx plus b. So this, I will not ask you on a test. Alex might ask you a couple times, so we do need to go over it. And you should be aware of what it is. Maybe you'll have a teacher that loves standard form somewhere down the line, but I just feel like it's kind of a waste of students' time. So it's just pretty, doesn't do anything else for us. So let's list the other two just so we have all three together. So standard form looks like this: no fractions, no decimals, X and Y are both on the left in alphabetical order, constant on the right. The first one we learned back in Module 6 was slope-intercept form. And that's probably the one most familiar to us. That one is y equals mx plus b. Uh-oh, forgot to shut the door again. Did you hear the big snore? And the next one is called point-slope form. And that was the one we learned in the last section in Module 7, Lesson 4A. And that was y minus y1 equals m times x minus x1. And remember, if you ever forget that, write the slope formula, cross multiply, set your two cross products equal. I've had students leave every one of these on their test because they go, I forgot the formula. But they knew the slope form. If you know the slope formula, you know this one. You just have to cross multiply. So you should never say, oh, I couldn't do that one. I forgot that formula, because it can be derived by cross multiplying the slope formula. Okay, so let's talk about standard form. So this is one of the three forms, which I told you. A, B, and C are integers. That means no fractions, which also means no decimals, right? So integers are positive and minus 1, positive and negative 2, positive and negative 3, 0. So A, B, and C will be all whole numbers and their opposites. So no fractions or decimals. It's just right up there, no decimals. I think everybody knows that. Every fraction can be written as a decimal. So when it says no fractions, that means no decimals too. The most common way to graph an equation in standard form is to find its x and y intercepts. And we did that in Module 6. X and y intercepts are 2 points where the lines cross the x and y axis, which we learned. To find the intercepts, first set x equal and solve for y. And we learned in Module 6, that's called the Y-intercept when we set x equal to 0. So x equal to 0, that's called the Y-intercept. Then we set y equal to 0, and we call that the x-intercept. So that's the easiest way to graph from standard form. Rather than take the problem and solve for y and do all that, it's easier just to do your values. So just like you did on your Module 6 text, when they asked you for y-intercept, you made x 0. So 3 times 0 plus 5y equals 15. 3 times 0 is 0. 0 plus 5y is 5y. Divide both sides by 5, you get y equals 3, which makes the y-intercept x is 0, y is 3. And most of you did very good on that on the Module 6 test, so I'm not too worried about that. X-intercept is when you set y 0, so you make that 0, so it'd be 3x plus 5 times 0 equals 15. 3x equals 15, divide by 3, x is 5, y is 0. So you plot those 2 points, connect them, boom, you got it graphed. So that's the easiest way to graph a line when it is in standard form. So find the intercepts, put the 2 points on, connect them with a straight line and an arrow. So when we have x equals 4, and they ask us to find the intercepts, back in Module 6 when they asked us that, I told you, okay, first thing you should notice is this is a special case. It doesn't have an x and a y. So I told you to get the answers from the graph. There's no need to do all that algebra because you can get it right from the graph. So here's the x-axis, here's the y. This one tells me this line only goes through the x-axis and it goes through at 4. So if it only goes through the x-axis, it must be a vertical line. And so then I can answer those 2 questions from my graph. Y-intercept, it never crosses the y-axis, so I write none or does not exist. X-intercept, where does it cross the x-axis? At 4, 0. So there's no need to do all that work. You can draw the picture, which you have to draw in the final anyway, and draw in your Chapter 7 test, so you need to get good at drawing it. So you really don't need to do anything when it's special cases. You can just answer the questions from the graph. It never crosses the y, so we say no y-intercept or does not exist. It crosses the x-axis at 4, 0. Okay, let's go ahead and look at the next page. So slope-intercept form, that was the second one I had you list on the front page. That's the one we've been working with the entire class, or at least Module 6 and 7. So slope-intercept form is y equals mx plus b, remembering that m is your slope and 0 comma b is your y-intercept, which always has to be written as a point. That's why I wrote it as a point. When it's the y-intercept, x is 0. Slope-intercept form is the second form. The letters m and b represent the slope and y-intercept, which we already wrote. You can graph linear equations by, and this was on your last test as well, first you plot the y-intercept, and then from the y-intercept you do your rise and your run. So let's say we had y equals 1/3 x plus 2. Because I kind of like to demonstrate this because it makes more sense when you see it. And like I said, you already did this on your last test, but it's been a while, so I would like to review it. So does everybody agree our y-intercept is 0, 2? So x is always 0, so we plot that point. That's what step 1 says, plot the y-intercept. Then we do our rise and run. Well, our rise and run on this one that I just made up out of the blue is 1/3. So that means from that point, we put some more. You rise 1 and run 1, 2, 3. So rise 1, run 3. And that's what you should have done on your last test. And then you can rise 1, run 3, get another point, or you can go down 1, back 3. But that's how you get the first 2 points. And then, of course, you connect them into a nice straight line. So that was on Module 6 test, but I just wanted to refresh your memory, because I do know I put it on the final exam, so it's one you're going to have to know again. So plot the y-intercept. From the y-intercept, do your rise, do your run, get your second point. And then if you want to rise 1, run 3 more, you can get another point. Okay, so, and remember, if the slope is a whole number, you put it over 1. So if the slope had been 3, you would have made it 3 over 1. You would have rose 3, ran 1, just so that you remember about that. So example, write the equation of a line that has a slope of 2/3 and a y-intercept 0.6. Well, this is my what of my equation? It's my m, right? And this is my, since x is 0, this is a y-intercept, so this would be my b, right? So anytime they give you a point where x is 0, I don't have to do that whole y minus y1 equals m times it. Could you get the right answer if you did that? Absolutely. But if they're giving you the y-intercept, which I know they are because x is 0, boom, your b's already there. So you just go down the line and plug in. So don't make more work for yourself than you have to. So in place of the m, plug in 2/3. In place of the b, plug in 6. Boom, done. So anytime they give you the slope and y-intercept, you can go right to the answer. It's when they give you another point, like 1, 5, that you have to do the whole y minus y1 equals m times x minus x1. So that is slope-intercept form. And then the last one is what we learned in our last lesson on, it was still lesson 4, but was student pages A. We learned point-slope equation. Let's highlight these since this is pretty important stuff. I know we have them written on the other page too, but the more you see it, the easier it will be to remember. So point slope gives me a point. There's my x, there's my y. And remember, we use the x1 and y1 as our point, and then it gives me a slope, hint the name point slope. So slope is m. So we learned in the last lesson that we can do point slope with 2 different scenarios. If they give me a point, say 1, 3, and a slope 3, I can plug in the point 1, 3, and the slope 3, solve for y. So we replace the slope, we replace x1, we replace y1, then we solve for y. And usually, just like we said in the last one, usually we want the equation y equals mx plus b. 99.99999% of the time, that's the form we want, because that's the useful one. We can graph from that. We also learned on the last 2 examples we did on lesson 4A is that you can do point slope with 2 points. But remember how we had to do that extra step at the beginning? First, we had to find the slope. Then we plugged in m and one of the points for x1 and y1. And remember, use the point that's smallest, less negatives, but in the end, it doesn't matter which one you pick. And then we just follow the steps from above. So that, except for the standard form, all a review. But it's kind of nice just to recap it before we move away from it, just to make sure everybody's solid. Okay, so we got about a minute. We might be able to do one here. Start one anyway. So warm up. That means it's a review. Determine the equation. So do you guys all know that's the same thing as write an equation or write a linear function or write a linear equation? So the minute I see 2 points, I go, oh, I have to use my new formula, y minus y1 equals m times x minus x1. How do I know that? Because it's 2 points. For y equals mx plus b, I need a slope and the y-intercept. For slope-intercept, I either need 2 points or a point and a slope. So these first four are a review of the very last thing we did in lesson 4.